and see if things work. Hi, welcome to Meeting C++ Live with Sean Parent, my guest today, this evening. We're a bit later than we thought because I had a technical difficulty with USB not working under Linux, and now we're on a different machine. And I'm not sure if Sean needs an introduction, but maybe we'll start with an introduction of Sean. Sean?
Sure. So I'm Sean Parent. I'm a principal scientist at Adobe Systems. I'm currently working on the Photoshop team. I've been doing software engineering for a long time now. I've worked at Apple, Adobe, and Google. At Apple, I worked on the PowerPC team. At Google, I worked on the Chrome OS team. Most of my time at Adobe, I guess now, has been working with the Photoshop team, although I also worked on Lightroom Mobile for a while and Lightroom Web, and I ran Adobe's ST Lab, which is Software Technology Lab, research team for about 8 years.
Oh, nice. So you're known for lots of talks in the direction of, telling people what to do or what not to do. Most famously, probably your talk, C++ seasoning. And I got you to know in 2012, where you also keynoted C++ Now, which was a very awesome keynote back then, which I watched and kind of misunderstood your feelings towards shared pointers.
Okay.
So
you thought I liked them, or?
Yeah. There was there was a heart drawn around shared pointers, and so I thought we step into this was a short. What is your opinion on shared pointer?
Well, I think my usual statement is a shared pointer is as good as a global variable. The point there being shared pointers, if they're mutable, break local reasoning. When you're reading a piece of code and you come across a shared pointer, just like when you come across a global variable, it's very difficult to be sure, if you call a function, if that function is going to actually change the value in that pointer. And what's going on the other side of it. So, and what the ramifications are of you changing that pointer, what other objects within your system you're affecting. So I'm not a fan of shared pointers, unless they're const. If you have a const shared pointer, or I should say a const shared pointer, a shared pointer to a constant value to an immutable object, then you restore value semantics, and so that's fine.
Okay, yeah. I came to mostly share that opinion, even if I in some programs use shared pointer, because just having shared state, shared constant state is very practical. But
so you actually broke.
Actually, there is something new with your career this year. I see that you started a website called ST-Labs.cc, and there's like lots of there's a new concurrency library from you. There's tips on this website. You have your own blog there. You want to talk a bit about ST-Labs?
Sure. So this came about because I ran Adobe Software Technology Lab, as I mentioned in my intro, for about 8 years. And the Adobe Software Technology Lab is no more. And I think we did a lot of really good work in the lab. And so the stlab.adobe.com website has kind of slowly been decaying, and it's been harder and harder for me to get our IT department to keep it going. So I got permission to move the libraries to my GitHub site, which is github/stlab, and I brought up the STLab website. And it's a place where I can continue kind of some of the the work that we were doing as part of Adobe Software Technology Lab. So we've moved over the Adobe source libraries into our GitHub repository. The old STLab wiki was shut down, so there's a legacy section on
So I
the
just went
stlab.cc.
to the website or from GitHub to your GitHub page. You quickly so I see there's like Adobe Platform Library, Adobe Source Libraries. I remember that Adobe had like their own open source library for a while.
Yep.
And that library is also part, or that is your work.
It's not entirely my work. I mean, we had 5 people in the software technology lab.
Sure. But you contributed to that.
Yeah, I contributed a lot to it and did a lot of work on it. And like I said, I got permission. We moved it under the Boost license, so that way if somebody wants to go through the efforts to contribute all or parts of it to Boost, that should make it easier. And I've split it out from Adobe's website onto mine. Adobe still has lots of open source efforts going on, but this one now is continuing outside of Adobe.
Okay. Actually, there's I've been talking about Boost this spring and about their issues, and I think that the Adobe libraries share a different, like the same issue with having old code, which is like pre C++ 11 or pre some things which we have now. How have you dealt with updating the code of your library?
Yep. I've been working on it slowly. Of course, the library now builds with C++ 14 correctly, and there were a number of things that we had in there, like we had our own move semantic library that relied on RVO to do moves, and I've pulled that out in favor of using R-value references. We were relying on Intel TBB library for atomics, so we got rid of that dependency, and now we're using STD atomics. So I've been slowly going through and cleaning things up and modernizing it. There's still a fair amount of work to do there, and yeah, C++ 11 was a big shift, and I think it'll take us a while to get caught up. In general, I don't think the libraries are quite in as bad a position as some of the Boost libraries are. I mean, some of the Boost libraries are still emulating variadic templates.
Oh yes,
so you get like wrapper after wrapper after wrapper on a single function call, and it's kind of painful.
Yeah, I've been experiencing that in my code too. So that's something I'm really looking forward to moving to, actually, not simulating variadic templates anymore. And let's go back to the STLab page and just quickly talk about what STLab is. So it seems to have to do something with your work at Adobe. So I see like these 3 icons on top, which is libraries, tips, and legacy.
Yep. So let's take them one at a time. The libraries is where the initial plan for that section was to slowly start to move over some of the Adobe source libraries into STLab libraries as we clean them up for C++ 11. But a while ago, I gave one of my Better Code talks on concurrency. I think the first version of that talk I gave in Moscow, now about 2 years ago. And I open sourced the source code for the talk I had done for that library. And Felix, who's one of the people who's in the chat here.
Yeah, I've seen that Felix Petriconi is one of your contributors, and I'm just gonna go into the page for concurrency now.
Yeah.
So I see that three prominent things are there, which are like channels, executors, and futures. So what model is your concurrency library built upon on?
So the idea was to say it started based around futures, and I was working on a project where trying to use STD futures just didn't work for a number of reasons, and the conclusion I came to is I really want futures that have regular semantics, and meaning that I can copy futures, I can add multiple continuations to futures, and they would work better. So I wrote a small library to do that, and Felix and myself and Foster Brereton have been collaborating to expand on it. So that's kind of the heart. And at the last C++ meeting, there was an effort to potentially pitch this for standardization. So there's a paper written up on what we've done and why. And in general, at this point, I think it's a better future library. We've taken some feedback from the committee, and we've been working on our 1.1 release, which we were supposed to have out earlier this week, and is pretty close. But I've been tied up with other things. So hopefully we will get that out quickly.
That's interesting. So I see you have a bunch of examples on the page. Is there like one particular example we should take a look at?
Oh, let me take a look here. I got to catch up to you.
Okay.
Let's see.
So yeah, in the meantime,
Yeah.
just can talk about the new web page. Meaning C++ has a new web page now with the schedule and the speakers and talks. Everything is online. Also, most of the old links still worked on that. And for those who don't know, this year's conference is the one conference where Sean will do the opening keynote. We probably might have time to talk about it later a little bit. And also Felix Petriconi is having a talk on the futures which Sean was talking about.
Yep. Just a quick glance. I don't think our future example here is particularly interesting because it's just trying to be a very quick example to show you the basics of how to use a future. But if you look at the channel example, it's a little more interesting. The idea with a channel is to start to extend the idea of a future into more of an RX style programming, where instead of it being an execute once model, you can create pipes and send data down the pipe in an asynchronous fashion. So in the example here, we can
have a sender and a receiver.
Yep. So we've got a receiver, and we pipe. We open a channel which gives us a sender and receiver, and then we can pipe the receiver into a little lambda expression there to just stream it out, and then send a bunch of values, and we'll stream it out. And the hold value returned by that pipe is actually another receiver, so you can keep extending the chain.
That's interesting.
Yep.
And so I like the simplicity of this. That it's just I really like the API, and that you seem to be able to concat with the piping thing. So are you actually able to build pipelines with this?
Yep. You're able to build pipelines that execute asynchronously. And you can control the scheduler. So one of the issues with much of the current STD async stuff is it always schedules items onto threads. There's a little hand-wavy caveat about that, but you don't have a lot of control. So the idea with executors is to give you control, and we provide a default executor which defaults to either a platform thread pool like Apple's libdispatch or Windows thread pools, or we have our own portable implementation of a high performance task stealing thread pool as part of the library. So if you're running on Linux and you don't want to be using libdispatch, we can provide our own implementation. It also works under Pinnacle inside the Chrome browser if you want to build that way.
Okay. So would you say that your concurrency library is production ready?
It's certainly already been used in production code. I initially wrote it for work I did for Lightroom Web, and that's where the Pinnacle support comes from. There's also support for asm.js in there. So that was the original target that led to it. So yeah, I would consider it production-ready code. There's still lots we want to do to flesh out and complete the library, but it's in a solid state. We've got a number of unit tests that run against it, and code coverage tests that are included in that.
It's difficult to get all the things started that's really needed for a library to be covered.
Yeah.
Actually, we have a question from the chat about you had also a range library in the ASL, and there is a question if you did or have any contributions to Eric's work with ranges in the V3 library.
So Eric insists on listing me as a co-author of the range library. I think that's very generous of Eric. It was his full-time job to create that library, and he did a huge amount of work on it. My contribution was really in the very early stages. We had a working group for the ranges TS, and I shot down a bunch of proposals. And when Eric started making proposals, I gave him a lot of input that kind of shaped it. And I've had conversations with Eric about this. He claims that my input completely changed how he thought about the problem, and he thinks got him on the right path for the range library. And so he wants to continue to list me as a co-author. But really, I think, like I said, I think that's very generous. I didn't write a line of that paper. But yes, I certainly had some influence on it in the early days.
So I'm just looking at the executor example, which is kind of the same. So you can also pipe executors, I see from that.
Well, the executor here, so you can pipe in executors into your pipeline so that you can change the policy for how following things in the pipeline get executed. So in the example here, our default executor, like I mentioned, is executing things on a thread pool. But if you pipe it to an immediate executor, then things that following the add sign there, that means execute that lambda on the immediate executor.
So the objects in your library share certain interfaces.
Yeah, to some degree. So
okay.
So one thing that we've been debating is I'd like to kind of add the ability to use a pipe operator instead of using a .then for continuations on futures. But that gets a little contentious because it's a little misleading, because although you can chain them together, they're still an execute once. So technically you're not really building a pipeline. But I think it's a more natural syntax.
Yeah, yeah, I like that. But I mean, yeah. So traditionally, the pipe operator is what is used there, and of course we would have some various other operators to overload to use it. But this is a nice syntax, which probably makes code easier to read than just using .then.
Yeah, I think it makes it both easier to read and easier to write. When you use a .then, you always have to remember to put that extra parenthesis after the curly brace. Um, and, you know,
Talking about
most,
then, I also, of course, have to look at the example for then or the documentation for then. There's one example. But so it's just in the normal .then what we know from other libraries in the standard. So
it's a similar .then. The difference is that, like in the Boost libraries, um, and in the standard libraries for proposed standard for .then, uh, you can't have multiple .thens. You can't attach multiple continuations to an object, so you can't do a fan out mechanism.
And you can do that with your future?
You absolutely can do that with our future, and we're trying to keep the cost very low. So if the future that you're attaching a .then to is an R value, then you could only attach one .then, and so we can actually optimize for that case. So you don't pay a penalty, but we can still allow you to do fan outs and attach multiple features.
Sweet. So maybe we move on to tips.
Sure. So the tips section, I've got a couple of tips pending. Right now I only have two in there. Inside of Adobe for a number of years, we've had this C++ mailing list, and occasionally I will blast out a coding tip on the mailing list. Usually it's in a response to either a question somebody asked in an email, or asked on the mailing list, or in...
I see one on library coding style, which is particularly interesting to me because I just recently started this RCPP review community, and so you quickly want to talk through your thoughts on like how how should you have, which style should the library have?
Sure. Well, this is a pretty terse thing. I mean, it's not going into things like naming conventions to a huge degree, but this tip actually came out of my work at Google on Chrome OS, where we started putting together a bunch of libraries, and many of them had been forked from the same root, and so we ended up with massive collisions. And so this is basically talking about, all libraries should be in a namespace, all macros should be prefixed with a unique name.
Okay, so very basics.
Very basic stuff, and you want to make sure that, if you fork a library, that you go and you rename the symbols in it so that you don't end up with conflicts when things come back together. But it's amazing to me the number of times that people don't follow this. And right now, I'm working through a bunch of issues on Photoshop where there are DLLs that we would like to turn into static libraries, but people have used DLLs to hide names of what would otherwise be conflicting names. And that becomes a huge problem.
Yeah, it's sure. And then your sins gets exposed, and talking about library coding style, what I found very interesting was in the second meeting C++ conference, we had Eric Niebler talking about library design in C++ 11, and he mentioned things like you should have versioning namespaces from the start, that you could switch later to a new implementation with a versioning namespace relatively easy. And yeah, unfortunately, that was a very, very good keynote, but we lost our video recording of 2013 then. And so I think you can find a C++ Now recording, because he repeated that talk at C++ Now 2014, and that recording should be online. And
Okay.
I remember that previously to this talk, you gave a talk at C++ Now back then on destructive move. You want to say something about move and your opinions on destructive move, or?
Sure. You can read if you go to sean-parent.stlab.cc. I've got a couple of blog posts there. I don't write blog posts very often, but there's one there titled "About Move," and that came out of the
Yeah.
talk you're directly referencing, and so it's got a number of links there. And Eric Niebler and I just had a bit of a discussion about what the post conditions of move should be, and I made a comment that move, as it's currently described, is both an unsafe operation, and I mean something very specific when I say that, but it's both unsafe and inefficient. And that if we had a destructive move, in many cases, not in all cases, we could both gain efficiency and gain safety. Now, I actually wrote a what I call a non-proposal for destructive move early in the days of move, and we had move in ASL libraries long before they were in the standard. We knew about the notion of destructive move, we just didn't know how to implement it. And I think we kind of figured out how we would go about implementing it, but too late for the R value standardization process. That was too far along before we kind of figured out how a destructive move would actually work. And now I think it would just add another unnecessary layer of complexity. I mean, it does gain you a little bit, but it's not enough to be of value, which is why I called it a non-proposal. But a lot of people have misunderstood me when I say that move is unsafe and inefficient. They think I mean that I don't like std move. I do like std move, but unsafe means something very specific, which is that it can potentially violate the invariance of your application. It leaves the object that was moved from in an undefined state. And
you would prefer that this object is destroyed?
If the object were destroyed, if it completely fell out of scope, then that would at least be safe. It would also be more efficient, because in order to allow you to destruct this object that's in an undefined state, you frequently have to write something back into it, right? You have to null a pointer or something so that you don't go and delete a pointer that's already been deleted in the object, as one example. So having a destructive move is potentially safer and more efficient. So that's what I mean by that. Move itself is still a perfectly fine operation. I think people just need to understand that it comes with a couple of sharp edges. So okay. Where the argument comes, the standard says that the state of an object that's been moved from is undefined, but satisfies the invariance of any use of that object, and that's complete nonsense. There's no way in practice to do that. So if you read this post about move, it goes in and explains that in great detail.
Seems the stream is lagging. I'm not sure. Let's see what. Okay. I think I'm quickly going to restart the stream
Okay.
to see if that works again. Okay, we're back with Sean Parent. Just restarted the stream because it was probably lagging a little bit. As people mentioned in the chat, I hope that fixes this. And so maybe that fixes it and maybe it doesn't. But I have a recording of this here also too. And maybe, so we were talking about destructive move, and as it's currently the standard is not supporting this because defines like, move from object is left into a certain state. And let's move on, because while we are in your blog, I see also you had in the summer a post about futures. Is that something we already talked about, or?
That was. Let me pull that up here real quick.
Your future ruminations blog post.
Ruminations,
yeah. July.
Yeah, that was came about because there was a discussion of futures and executors, and there were multiple future proposals, and including our future proposal, and to kind of help the standards committee as they were working through these papers and discussions. I wanted to write something up that kind of outlines the space, right? What are the things that you could possibly do with futures, and what do futures semantically mean, and what are some of the trade-offs inherent in that? And so this talks about things that some of the things are in our library, and some of the things discussed here are not in our library, right? An example of something that's not in the library is the idea of task promotion. Right? Can you, if I've scheduled an asynchronous task, is there some way through a future that I could promote that task either to execute at a higher priority within a thread pool, or to execute immediately? And so deferred execution futures in the standard library, that's an example of being able to do task promotion. It's basically saying that you've got a never execute executor. So you've got something that you say never execute this thing, but at the point where you do .get, you promote it all the way to immediate execution. So that's one way to think about deferred execution. But that's just one point in a continuum of what promotion could mean. So this was just a write-up to provide some context.
Nice. So then there's we're through the tips section. We're through. Should we go in the legacy section?
Sure, if we want to take a quick look at the legacy section.
Yeah, let's have a quick look at Sean Parent's legacy.
Yeah, so this was because we had a wiki as part of stlab.adobe.com that had...
You're now hosting this also at STLab.
Yeah, at stlab.cc. So our Adobe's IT department contacted me and said that they were going to decommission the old wiki.
Okay.
And I didn't want all the information that was up there to get lost. So I basically went through and did a wholesale conversion of the old wiki into Markdown, hosted up on GitHub, and just brought over all the content.
Wow.
And so down at the bottom of the page there, it's got the complete list of page there. Some of it is just...
through this. So this is basically the old internal wiki of your lab.
Not internal. It was an external-facing
Oh,
wiki.
okay.
But
Yeah,
yeah,
okay.
it's the old external-facing wiki from the lab. Yep. And so, it contained some of the design rationales around some of the ASL libraries. It contains links to papers and presentations done by myself and other folks in the lab and
But this
people
this
we were
is,
collaborating with.
as far as I understand you, this is read only. This is just the past.
Yes, this is just
Okay.
read-only. This is just the past. And it's
So
there to archive some old work, and it was interesting when I went through it. It's like, wow, there was a lot of good work in the lab, and some of it got completed, and some of it is just good ideas that should still be finished.
and currently your work is focused on the concurrency library.
Currently, we're focused on the concurrency library in our 1.1 release, which I mentioned will be coming over soon. We will be stealing a couple of things from the ASL libraries and moving them over to the ST-Lab libraries as part of our work on the concurrency library. So one of those things is ASL includes a copy on write implementation. Which is kind of a value semantic copy on write wrapper that can work with any class. And we kind of dusted it off and refreshed it and are going to include that as part of our 1.1 ST-Lab library release, moving it over.
So in 2013, you gave this seasoning talk.
Yeah.
And one of the things you very prominently displayed there was the algorithms in the standard library. With C++17, we get a whole set of new algorithms which are able to run in parallel. So I wanted to talk about that with you. Should one now prefer like the parallel set of algorithms instead the normal old set, or what kind of do you have taken a look at this? And
I have
thoughts?
taken a look at it. My my current recommendation would be, if you're writing new code, it's probably best to just go ahead and say that you want a parallel launch policy on your use of the algorithms, unless there's something else that would prevent that from working. But as long as say you've got a container of regular types, it should work fine. But there's a big asterisk there, which is things like the standard libraries that are included with Clang don't actually yet do a parallel implementation. It's unclear how the parallel implementations are going to play with platform code. We don't have full-on executors in the standard library yet. So, is parallel execution going to be, say, on a Mac or on iOS, making use of Apple's libdispatch to do the parallelization, or is it going to be spinning up yet another thread pool? And if it is spinning up yet another thread pool, how is that going to play with the OS thread pool? And so if you're doing kind of high performance production stuff where you really want to be controlling what resources are brought upon the machine, it may or may not become a problem for you, as those things get turned on. And
That's a good point. Yes.
yeah. So for most kind of casual code and most application usage, it's probably just a good idea to get in the habit of saying, yes, I want it to be parallel, and it will probably just be a free win for you where that's available. But be aware that how it interacts with the platforms hasn't yet shaken out. And I'm hoping it will just be good. I'm hoping that there's enough right people on the teams that will happen.
Yeah, I have no doubt that this will happen. It's just, I think, a question of time. And
Right.
also, yeah, C++17 support. I mean, it's amazing to see that we already have that, and most things are implemented in most compilers, and we just have like a week long of C++17 being kind of an official standard, as Herb did let us know last week. So
yeah, that is such a huge change compared, for anybody who lived through C++ 98 and C++ 03, where you had, a decade of pain.
True.
It's so nice the compiler vendors are going so much faster.
Yeah, big shout out to the vendors there. I'd like to go over to a more open format now and to see if we get actually any questions in the chat. So if you want to ask any questions, just have them in the chat. And well, actually, I haven't talked about you with your keynote yet, but just do you have any ideas what you want to do as a keynote?
Yeah, so I've got a couple ideas. Right now, the direction I'm leaning is to do my talks recently have had this better code theme, which basically comes out of my seasoning talk. So this one would be better code, human interface. And the idea is to talk about the relationship between good code and a good human interface. So it's not actually talking about how you would go about building buttons and checkboxes and things like that, but how if you write a good, clean application core, that it becomes easier to bind a good human interface on top of that.
So you mean human interface like a UI?
Like a UI, exactly like a UI. Although it doesn't have to be even a graphical UI. It can be like, how do you do better command line arguments, or for a low-level tool, right? So
yeah, true. Command line is also a UI,
kind
of like the first, actually, and that's actually an interesting topic, because I know you have extensively worked with putting C++ into the browser and into Chrome and other browsers, into ASM.js and others. You want to talk about this work and your experiences?
Sure. So the browser work started as somewhat. Well, it came about. I had worked at Google on Chrome OS for about a year. I'd left Adobe. I went to Google. I worked on Chrome OS for about a year. And while I was at Google, the job that I was hired to do but never got a chance to do was to look at the problem of how do you build a large-scale application, something on the scale of Photoshop or Microsoft Word or Excel or something that would run inside the browser. And so I'd given a lot of thought about that, but I didn't actually get a chance to work on it at Google. But I did, while I was doing some work on Lightroom Mobile, managed to carve out some time and see, could I take the Lightroom rendering system and get that running inside the browser. And this is a heavily threaded piece of code, a very large code base. Something on the order of about 10 million lines of code, at least for scale. And it's an image processing pipeline. It's a high-performance render-on-demand image processing pipeline. And so I worked with somebody, Paul Holland, and he and I sat down and got the code running first inside of Google's Pinnacle, which is this portable native client code, which basically lets you run through a client compiler and run in a very secure sandbox native code inside the Chrome browser or on Chrome OS. And then we took the same code and got it running compiled to asm.js with Mozilla's Emscriptum compiler. And surprisingly, we got good performance out of that too. Now that required a fair amount of work to actually make this heavily threaded system run inside of a single thread, because JavaScript doesn't have threading.
Mm-hmm.
And that's actually where the concurrency library came from, which is how do you structure code that can scale from a single-threaded environment into a heavily multi-threaded environment and scale with good performance across that entire range.
So is your new concurrency library also able to run on a single thread?
Yeah, so the new concurrency library, including things like the channel stuff that was first written so that we could write things as coroutines and have them execute inside of a single-threaded environment, where things are basically chaining as coroutines off the JavaScript main event loop. And so the concurrency library has an option that you can switch to say, make my default to compile for asm.js and make the default executor be your JavaScript run loop, and it will work.
Okay.
So that's where that came from.
Mm-hmm. So there's actually unrelated to this. There's two questions from the chat. The first is about your inheritance as a base class of evil talk. And the question is, you mentioned in this talk that most often types in an inheritance hierarchy don't have to be modifiable or mutable.
Yeah.
Why is that?
Yeah. So ignoring inheritance, if you think about the idea of polymorphism and what it means to have something that's mutable and polymorphic. What that typically means is you want to be able to at runtime do something like swap out an internal data structure, maybe use a deck instead of a vector or something like that. But that actually changes the performance guarantees of what the objects are. What you most often see people using overridable methods that are setters of some sort to do is actually not to provide a polymorphic mutable implementation, but to provide change notifications on mutation. So it's not the set operation that's polymorphic, it's that you want notification when a non-polymorphic set changes. Okay. So the statement there is not that the objects themselves are completely immutable, it's that the polymorphic objects are not mutable. The polymorphic aspects of the objects are not mutable. So typically in a system like that, what you want instead is something like a delegate, right? You want a delegate so that you've got a notification to say, or some kind of observer to say, hey, this thing has changed and this is how it has changed, because you're not actually trying to change the behavior of the set operation. There are some valid exceptions. They're just exceedingly rare.
And the second question is about shared pointer. What is so wrong about using a shared pointer to a mutable type and forward a mutator through the external interface to the synced in argument in order to modify it?
Yeah. So the problem with shared pointers in general is, like I said earlier, they break the ability to reason locally about the object. And that means that if I have a shared pointer to something, I have to be exceedingly careful not to do something like hand that to another thread, because I have no guarantees that if that other thread were then to either read or write to it, that there's some underlying synchronization on the object to make that be a thread-safe operation. When I'm reading a piece of code and I see a shared pointer in there, and I'm hanging on to a shared pointer, and I make a function call, I don't know how that changed the state of that shared pointer, or if it changed the state of that shared pointer, if there's something else holding on to it. So it just breaks your ability to do local reasoning.
And yeah,
You know,
it's just
it's
the
it's
mechanics
this.
of shared state. It's it's not like a global variable, but for the code accessing it, it is a global variable.
Yes, yes, yes. It's effectively a global variable when it comes to trying to reason about that piece of code. It's it's exactly the same reason why functional programming uh, 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 can provide such strong guarantees, right? Right. In a functional programming environment, you remove the ability to mutate the objects, and that means that I can freely share my objects between threads, and I always know that an object isn't changing out from underneath me, and so you have very strong guarantees, and you have the ability to reason locally about it. Now, there's really not any problem with being able to mutate an object in place and being able to reason about it, so long as you know that you're the sole owner of that object and nobody else is mutating or reading from that object while you're mutating it. So it's not the immutability aspect; it's the sharing aspect that you're trying to get around.
Mm-hmm. Yeah. So there's no more questions from the chat as far as I see. Maybe we get one or two more. But it's also now a little bit of an hour, and we started late. So Sean, is there anything else you want to say?
No, I mean I'm looking forward to seeing you again in person here, Jens, at your conference in just a couple months. Um, I'm hoping people who are in the chat or who watch this online attend the conference. Very exciting. It's been, wow, I think it was 17 years since the last time I was in Berlin.
Oh, yeah.
So looking forward to seeing how the city's changed. And
Oh yeah, Berlin has changed a lot. That's
it
17
was
crazy
changing a
years.
lot last time I was there, so I imagine it has changed a lot.
Well, at least the wall already had fallen. Scott Myers was like, "Oh, the last time I was here, the wall was still standing," and he was
Oh, wow.
on the east side and told some funny stories about that. And yeah, so I'm looking very much forward to the conference. Next week I'm leaving for CPPCon. Are you going to be at CPPCon?
I am not. I'm going to miss CPPCon this year, unfortunately. Um,
Okay.
just didn't work out. Hopefully, I will get out there next year. Um, yeah, I'm all. That's one of John's conferences, and
Yeah.
I'm that and C++ Now, and I think C++ Now for people who get a chance to go, that is my favorite conference, having not been to Meeting C++ live yet. But that's another really great conference.
I
Small
have to
venue,
agree with
very
you
nice.
there. I think that C++ Now is a fabulous conference, especially for those who are already a bit in the advanced field of C++. It's every year a blast. And with that, I don't see any more questions. I think we're through. Thank you for being my guest, Sean. Thank
Hey,
you for the
thank you for having
questions.
me on.
You're welcome. And with that, I think I'm gonna see you next in Berlin. So
Okay.
see you, and hope to see some of you which are viewing at CPPCon or later at my conference or at the Qt Dev Days, where I'm also going to be, though the next weeks are going to be quite stressful for me. And with that, we're done. Thank you for listening. I'm not sure when we have the next episode and about what. Next week, I'm talking about starting with C++ at my user group, which actually is that's something I could ask you, Sean. How would you start C++ today? What would your advice be to beginners?
That is really difficult, I think, and I am probably the wrong person to ask. I find that things that when I'm having conversations, things that I think are self-evident, other people think I'm nuts and don't quite see how I have that perspective. I find teaching C++, which I do from time to time, to be incredibly challenging. Um, I'm I'm somebody though who thinks that the right way to learn something is to learn the foundational material. I think to learn how to program in general, you need a fairly strong understanding about how the machine works, and I think you should actually learn a little bit of assembly language and learn how transistors work and learn what stacks and heaps are, and come at it from the very, very, very bottom up.
Okay.
Uh,
Sounds like an interesting approach.
I think it's a unique approach, at least.
Yeah. Okay.
But yes.
Okay. And with that, I'm going to end the live stream.
Okay. Okay.
Thank you for listening.